All right, hi folks, Larry Mussolino here. I wanted to record a video for STAT412. This is the Module 6 homework. And also wanted to show how an Excel workbook can be used to help with confidence intervals, which is the main topic here in Module 6. So quick preview, in Module 6, we're going to be talking about 4 kinds of confidence intervals. There's a confidence interval for the mean when the population standard deviation is known. Population standard deviation, we use a simple sigma. There's another confidence interval for the mean when the population standard deviation is unknown. Really, then we only know the sample standard deviation. Sample standard deviation is the letter S. Then there's going to be confidence intervals for proportions, and then confidence interval for variances and standard deviation. So these are the 4 confidence intervals. And if you notice, there'll be 4 sections in this Excel spreadsheet to cover those 4 scenarios. So there's a section A, there's a section B, a section C, and if I scroll over a little bit, there's a section D. And this spreadsheet is posted in course announcements. And so let's go through some examples to see how to use this calculator and also talk about the, the theory behind these confidence intervals. All right, well, let's take a look at this first example. It says, what is the sampling error here? Well, what we'd really like to know is a value for a population mean. We call this a parameter. Well, the problem is we usually don't know that because it's very difficult to collect data from an entire population. So instead, we use sample data. And we use the sample mean as a way to estimate the population mean. The sample mean is X bar. The population mean, we use the Greek letter sigma. And here they're asking us, what's the sampling error? Well, really, the sampling error is just asking what's the difference between these 2 numbers. So all you have to do is subtract these 2 numbers to get the sampling error. And the reason it's an error is because of the sampling you did, you are introducing an error in the sample mean versus the true unknown population mean. Okay. So this is a simple question. All it's asking you to do is, take X bar minus the population mean. All right, let's go to another example. All right. So here's the setup when we're calculating confidence intervals. Step 1 is you calculate a sample mean, X bar. Step 2 is you calculate the margin of error. Now, we'll talk about this in a minute. Actually, we're going to let the Excel spreadsheet do that for us, E. And then when you want to go to form the confidence interval, you take X bar plus E. I'm sorry, let me write as X bar minus E to start with. X bar minus E. This is the lower bound. And X bar plus E, this is the upper bound of the confidence interval. All right, so when you find a confidence interval, you're really finding 2 numbers, a lower number and an upper number. All right, well, what this problem is asking you is imagine you have this confidence interval from 2.6 to 3.8. 2.6 is the lower bound, 3.8 is the upper bound. What is the margin of error and what is the sample mean? Well, one way to think about this is visualize it on a number line. Let me mark the lower bound here, 2.6, and here's the upper bound, 3.8. Well, the sample mean, X bar, is always centered in this interval. You can see it here. It's X bar minus E for the lower bound, X bar plus E for the upper bound. That means X bar is centered right in the middle. So to find the sample mean, all we have to do is take the midpoint. So to find find X bar. We're going to take the lower bound 2.6 plus the upper bound 3.8 and divide by 2 because that's the way you find the midpoint. And if you work this out, this will work out to be 3.2. So that's the sample mean, 3.2. Well, if you think about it, to go from X bar to the upper bound, we added E, the margin of error. So this distance is E, the margin of error. But the distance from 3.2 to 3.8 is 0.6. So that tells us the margin of error is 0.6. So visualizing this on a number line is a good way to picture a lower bound, upper bound, and X bar exactly centered in between. All right. So let's do a confidence interval calculation. So it says here, you're given a sample mean and the population standard deviation. Construct a 90% and 95% confidence intervals and interpret the results and compare the width. All right, now let me go to this Excel spreadsheet for a second. And let me actually make this a little wider here, I think, so we could see it. All right. Well, if you notice, section A here is to be used when the population standard deviation is given or known. Section B is when the population standard deviation is unknown. You only know the sample standard deviation. So an important part of these questions is to ask yourself, do you know the population standard deviation or do you only know the sample standard deviation? All right, well, I notice in this problem, it says assume the population standard deviation is 14.11. Well, that means I'm going to be using section A in the spreadsheet. Now, behind the scenes, what this Excel spreadsheet is doing is it's calculating the margin of error E using a formula that looks like Z sub C sigma over the square root of N. And that's what this margin of error calculation is doing right here. Then, to form the confidence interval, we're going to take X bar minus E, that's the lower bound, X bar plus E, that's the upper bound. And those are the two answers that are being given there. Okay, and what you can do in Excel is you can check out these formulas. For example, if I come here and click margin of error, you'll see this is taking that Z sub C number times the standard deviation divided by the square of the sample size. All right, well, in this Excel spreadsheet, the way this is set up is you enter data in the yellow cells and read the answers from the green cells. So don't type anything in the green cells, only type your input in the yellow cells. Let's do this problem. I'm going to section A. The sample mean is given as 82.32. 82.32. The standard population standard deviation was given to us as 14.11. The sample size was given to us as 59. And let's do 0.9. So this confidence interval here says enter as a decimal. So I'm going to enter 0.9 for the 90% confidence interval. And here is my confidence interval. The lower bound is 79.30. MyLabs is asking around to 2 decimal places, so this is going to be 79.30 for the lower bound, and the upper bound is 85.34. So those are those answers. Now they're asking us for the 95% confidence interval. Well, all I have to do for that is come and change this confidence level box from 0.9 to 0.95. And here are the new confidence bounds. The lower bound now is 78.72 and the upper bound is 85.92. All right, now here's another question. Which interval is wider? Well, Let me go ahead and graph this on the number line. The 90% confidence interval is going from 79.30 to 85.34. Let me plot the 95% confidence interval right below it. 78.82, 78.72. Well, that would be back here somewhere. And 85.92 would be over here. So I can see this 95% confidence interval is wider. And it turns out as you increase the confidence level from 90 to 95 to 99%, the confidence interval is going to get wider, because the wider the interval, the more confidence you have that the true population mean is going to fall within that interval. Okay. All right, and let's go down to the last part. This is kind of an interpretation question down here. And anytime you're interpreting a confidence interval, you're making a statement about the population mean. So the statement has to be about population mean. And if you notice, answer C is you're 90% confident that the population mean is between the bounds. Notice answer D is wrong. Answer D is not making any statement about the population mean. And answer A is wrong because they're talking about the population mean is outside the bounds. No, that doesn't make any sense. It's got to be inside the bounds. All right, let's do a couple more examples. Let me come here to, let's come here to number 5. All right, number 5 is asking us to take this data set and come up with a confidence interval. Now, I got to make a note here that it says, assume that sigma is 2.56. Sigma is the population standard deviation. So population standard deviation is given in this problem as 2.56. So I have to use section A again in the spreadsheet because population standard deviation is given. What I don't know is the sample mean for this example. Well, what I could do is quickly find the sample mean by copying this data set into Excel. So let me do that. I'm just going to open up another worksheet here and I'm going to copy this data to the clipboard, and then I'll copy it here to Excel, and I'm just going to say equals average for these numbers because I quickly want to get the mean. So it looks like the sample mean is 19.30125, right? Sample mean 19.30125. All right. They're telling us the population standard deviation here is 2.56. That's given in the problem. The sample size was, how many numbers do we have? 2, 4, 6, 8, 10, 12, 14, 16 numbers. So sample size was 16. And they're asking us for a 90% confidence. I'm going to put 0.90 here. And then here is the lower bound, 18.25. And here's the upper bound, 20.35. All right, so again, it was important to know here that the population standard deviation was given. When that happens, by the way, we're using the normal distribution behind the scenes to calculate this confidence interval. All right, let me go to another example. Let's come here. This is number 6. All right, it says you took a random sample of 20 people. The mean commute time was 30.9 minutes and the standard deviation was 7.2. So what I have to know here is that standard deviation of 7.2, is that the population standard deviation or the sample standard deviation? Very important that I know that. Well, what I have to do is read between the lines here a little bit. They're telling me I took a sample of 20 and the mean was 30.9 from that sample of 20. And the standard deviation was 7.2 minutes from that sample of 20. So this standard deviation really is a sample standard deviation. It's coming from that sample. We took of 20 people. So the sample standard deviation is 7.2. Well, in this case, we have to use section B in this calculator. And section B uses a margin of error that looks like this. It's T sub C S over the square root of N. T sub C is a critical value of the T distribution. So notice this section here, we're using the T distribution. S is the sample standard deviation and N is the sample size. T sub C is a number that corresponds to the confidence level. For example, if it's an 80% confidence level, that is going to allow you to look up T sub C. And here's T sub C. The formula you can see is in that cell. All right, so let's go to section B for this example. Let's see here. The sample mean was given to us as 30.9. So I'm going to type 30.9 here. The sample standard deviation was given to us as 7.2 minutes. The sample size was 20 people. And this problem is asking us for an 80% confidence interval. So I'm going to type in 0.80. Okay. So the margin of error is given here as 2.1. The lower bound is 28.8. And the upper bound is 33.0. All right, so I'm letting Excel calculate these confidence intervals for us using this built-in formula for the margin of error. Then when I want the lower bound, I'll just take X bar minus E. And that's how we calculate the lower bound. And then X bar plus E is the upper bound. All right, so let's take a look at another one. All right, well, this is one that's very similar because if you notice, they're giving us a standard deviation of 196. But what's implied is the standard deviation is coming from the sample of 10 cell phones. So again, this is a sample standard deviation they're giving us of $196. That means I want to use section B in this Excel calculator. Right? Remember, section A is only when you know the population standard deviation. All right, so I'm going to just go ahead and enter the sample mean here was $521.50. The standard deviation is 196. The sample size is 10 cell phones, and they want a 99% confidence interval here. So I'm going to enter this as 0.99. Here is the margin of error, 201.4. Here's the lower bound, 320.1. Here's the upper bound, 722.9. Okay. And again, our conclusion here is based on a comment that the population mean is between the lower and upper bound of this confidence interval. All right, let's talk about a couple of other types of confidence intervals. Let me jump to, let's do a proportion one. So let's do a proportion. So a proportion is going to be section C in this calculator. Proportion really means how many out of the total. You know, let's say I take a sample of 100 people and 20 are smokers. The proportion of smokers is 20 out of 100. All right, so here's the setup on this one. You took a survey, 715 people said they made a New Year's resolution out of 2005. Construct a 90 and 95% confidence interval for proportion. Well, this is section C in this spreadsheet. So notice here it says number of successes. Really, that's the number of people that said, yes, they made a New Year's resolution. So I'm going to type in 715 here. Number of observations is the total number of people I asked. This is like the sample size, 2005 for this problem. And they wanted a 90% confidence interval, 0.90 here. And here is the lower bound, 0.339. And here is the upper bound of the confidence interval, 0.374. Okay. Let me go back to the previous problem. The previous problem was asking you to kind of work backwards, because what they're doing here is they're giving you a confidence interval, and I'm going to sketch this on a number line. So the lower bound they're giving me here is 0.787. The upper bound is 0.811. This is a confidence interval for a proportion. Well, they want to know what is the sample proportion. We call that p hat. Well, p hat is always exactly centered, because this confidence interval, the lower bound is p hat minus e. The upper bound is p hat plus e. That means p hat is exactly centered. So p hat is the midpoint. So to find p hat, I'll take the lower bound plus the upper bound divided by 2, because that's the way you find a midpoint. And if you work this out, this works out to be 0.799. The margin of error is this distance from p hat up to the upper bound. So if you work that out, this distance is 0.012. So again, a little number line here is a good visual way to see the relationship between p hat, which is the center of the interval, and e, which is the distance from the center to the upper bound. Of course, e is also the same distance from p hat down to the lower bound. So e going this way is also 0.012. All right, folks, let me do one more confidence interval for variance. Let me find an example on that. All right. So what they're asking us here is find a confidence interval for the population variance sigma squared. And so what they're asking us here is use 98% confidence. That's what the C means. So 98% confidence. S squared is the sample variance, which is 20.25. And the sample size is n equals 20. All right, so I'm going to go over to section D in this calculator. Now, if you go into the textbook to look up how this is being calculated, this is using a distribution called chi-square distribution. And the chi-square distribution is not a symmetric distribution. It's a skewed distribution, something like that. And let me get the formula for you. Let me hold on one second. I just want to find the page in the textbook. Bear with me one second. Yeah, I think this is section 9.12. Yep. So I'm going to textbook. Let me erase a little bit of this stuff here. So I'm going to the textbook. Section 9.12. And I'm going to page 304. And you're going to see this formula. It says, if you want to form the lower bound of this confidence interval, this is going to be the lower bound here. And the upper bound Looks like this. And of course, the sigma squared in the middle is the unknown population standard deviation. N is the sample size, S squared is the sample variance. And these are the chi-squared cutoffs that you can either use a lookup table. So you can either use table 8.5 in the back of the textbook, or better, use Excel. So let me scroll over here to go to section D, and we'll do an example. And so if you notice here in this Excel workbook, you need to input the sample variance, the sample size, and what confidence level you want. Then this Excel workbook is going to calculate that chi-squared on the right end of the distribution and chi-squared on the left. And then here are the confidence interval for the variance and the standard deviation. If you remember, the standard deviation is just the square root of the variance. So the confidence interval for the standard deviations are just the square roots of the confidence interval for the variance. All right, so let's go do this example here. I'm going to enter the sample variance here of 20.25. So 20.25 in this first yellow box. Next, we need the sample size that was given to us as 28. And the confidence level here is 0.98. And Excel has calculated the lower bound, the lower confidence interval for the variance, 11.64. Upper confidence bound for the variance, 42.45. And then here's the lower and upper confidence bounds for the standard deviation as well. All right, so hopefully this Excel workbook saves you some time. And usually, this is not something that you want to do manually. You want to have an automated way to do this. So you want some technology to calculate these confidence intervals for you. So I hope the Excel spreadsheet is useful to you. All right, again, this Excel spreadsheet is posted in course announcements. All right, folks, let me know if you have any questions.